All right, so we talked about the law of sines and where it comes from. Now let's talk about how we can use it. So just a refresher, the law of sines, if you have a triangle ABC, the sine of one angle over its opposite side equals the sine of another angle over its opposite side equals the sine of the third angle over its opposite side. And that gives us three equations. Sine of A over A equals sine of B over B. Sine of A over A equals sine of C over C. And then sine of B over B equals sine of C over C. So, we talked about how since there's four missing pieces, four unknowns in each of these equations, we need three to solve it. So in this video, we're going to talk about when we have two angles and one side. All right, so when we have two angles and one side. So let's choose an arbitrary triangle. Triangle ABC. And we're going to have two angles and one side. So there's two cases for how this can happen. We can have two angles, and the side can be either between or not between. So let's say we have angles A and C. Let's say angle A is 72 degrees. And angle C is 31 degrees. And let's say we have a side between these two angles. Actually, let's do not between first. So, excuse me. Let's just say that BC is 17. Just all arbitrary values. So we have angle A, we have angle C, we don't know angle B, we have side A, we don't know side B, and we don't know side C. So there's three things that we need to find out. We need to find out angle B and sides B and C. Well, one of them we don't need trig for. If you know two angles in a triangle, you can find out the third angle in the triangle because all three angles add up to 180. So 72 plus 31 plus B equals 180. So 103 plus B equals 180. So angle B is 77. So we have one of our three missing pieces found for us. Fantastic. Now we just need to find B and C. Well, if we want B, let's look at our law of sines. And we could find C first, it doesn't matter, but I'm just going to do B first because it's alphabetical. So if we want B, well, B is right here, so we could use this equation, and B is right here, so we could use this equation. So if we use this one, we have angle B at 77 degrees, we have angle A at 71 degrees, and we have side A. So we could use this one. For this one, we have angle B, we have angle C, it's 31, but we don't have side C. So if you tried to use this one, you would have two unknowns, so you wouldn't be able to solve it. But this one, you would only have the B as the unknown. So we'll be using sine of A over A equals sine of B over B. So sine of 72 over 17 equals sine of 77 over b. Hey, it's a proportion. We know how to solve proportions. You cross multiply. B sine of 72 equals 17 sine of 77. And we want to get b by itself. So we divide both sides by sine of 72. Oops, not 27. So we're left with b equals 17 sine of 77 over sine of 72. That's the exact value of b, but we're just going to use our calculator for that. So we have our calculator. I'm already in degree mode, so I'm all set. So I'm just going to do 17 sine of 77 divided by sine of 72. Just punch it in and enter, and we get 17.42. So that's our value of b. That's the length of that side. So that's for b. Now all that's left is c. Now if this were a right triangle, we could use the Pythagorean theorem, but it is not. So we're going to have to use the law of sines again. So now we're looking for c, side c. So side c is here and here. Well, we know everything else, so we could use either one. But I always go back to the one that we're given. We're given a, we just found b. I would much rather use 17 than 17.42, which was a rounded value. So I'm going to use this one here. Sine of a over a equals sine of c over c. Cross multiply. Then divide. So divide by sine of 72, 17 sine of 31 over sine of 72. And that is the exact value of c, which we will just be approximating using our calculator. 17 sine of 31 divided by sine of 72. And it's 9.21. So that is the solution to this triangle. We use the triangle angle sum theorem to find the third angle. And then we use the law of sines to find the missing two sides. So that's if you have two angles and a side that's not between them. So the other case would be two angles and a side between them. So let's say we had triangle ABC like this. That's 108 degrees, and this will be 24 degrees. And let's say this is 31. So we have angles B and C. We don't know angle A. We have side A, but we don't know side B. And we don't know side C. Well, we can find out angle A pretty quickly, because if you have two angles in a triangle, then that with the third adds up to 180. So that's 132 plus A equals 180. So that means angle A is 48. All right, so we've got our angle. And now it doesn't matter which side we solve for first. We could solve for B or we could solve for C. Last time we solved for B first, let's solve for C first this time. Well, if we want C, if we look back, ooh, kind of erase as I drag, but you guys know what we're looking at. If we want C, C is here or C is here. So we could use sine of B over side B. Well, we don't know side B, so we can't use this one. It has to be this one. Sine of A over A equals sine of C over C. So sine of 48 over 31 equals sine of 24 over C. Cross multiply. Divide. Very important point I want to make. You cannot just divide those angles. That is not just sine of 1/2. So this would be the exact. And if we approximate that, 31 sine of 24 divided by sine of 48, we get 16.97. So that's C. And then lastly for B, if we're looking for B, we could use one of these two. I'm not going to use this one because we only just found C, so we'd have a rounded value in there. If we use this one, we won't have any rounded values. So sine of A over A, sine of 48 over 31 equals sine of B over B, cross multiply, divide, and then we use our calculator. 31 sine of 108, oops, not 180, divided by sine of 48. So 39.67. A quick check I always like to do before I move on is I just look at the angles and look at the sides and see if they make sense. And by that I mean the largest angle should always be opposite the largest side, and the smallest angle should always be opposite the smallest side. So our largest angle here is 108. That's opposite our largest side. Our smallest angle here, 24, is opposite our smallest side. So that checks out. So that's just a couple examples of using the law of sines to solve a triangle when you have two angles and one side. All right, have fun.